Okay, so in our last video, we were looking at mites and we found that we had 2 mites out of a sample of 600 bees. So we're picking up part 2 of this video series on controlling mites with how do we calculate mites? When we do our test and we come up with numbers, first of all, what numbers are good and bad, and what number means to do what treatment. So let's look at the mite count. In the hive that we sampled, we want to come up with a percentage. And the way that we do percentages, we say what percent is A of B, right? And so in our case, A is going to be the number of mites, 2. B is going to be the number of bees that we sampled, which is 600. So the question is, what percent is 2 of 600? And the way that you determine that is that you divide 2 by 600, and it comes up with 0.0033. So a percentage, then, you move the decimal 2 spaces to the right. So we go 1, 2, and so this means that this mite count comes up with a percent of 0.33. That's what our percentage is. So in this case, that's very low. It's a third of 1. So we don't even have 1 mite. It's a really good percentage. But let's say that you took a sample and it was 7. Well, in this case, we do the same math. 7 divided by 600 equals 0.0117. Move the decimal 2 places over, and now you have 1.17. Now, the question is, how many mites are too many mites in your samples? We used to say that 3% and below is optimal. You don't want to get above 3%. 3 mites per 100, for example. That would be 3%. But now we're really leaning toward no mites at all, which is impractical and possibly not achievable. But it's a goal. So in other words, I can't tell you, like if you have 0 to 4 mites, do this, 4 to 12, do that, 12 to 35, do this. We don't want to look at it that way because we want to keep our mite levels down all year long as low as we can get them. And that's what this class or this course is all about. How to help you achieve 0 or maybe down to, less than 3%, all the way down to 0 all year long. And that is the best way that we need to run our colonies. So just think of it as mites being very, very bad, and you need to keep them down to nothing. And let me give you a couple illustrations. So on this one, are the hive that we looked at, 2 mites for 600 bees. Now, let's say that hive, I'm guessing its population is 40,000. So we can do a little math here, and we sampled 600 bees, right, and got 2 mites. So let's get a little more number game going on here. So we'll say, Alexa, what is 40,000 divided by 600?
40,000 divided by 600 is 66.6667.
All right, so we learned that if we use this 600 number, that we come up with 66 times 600 is going to be 40,000. Now let's multiply 2 by 66. Alexa, what is 66 times 2?
66 times 2 is 132.
Okay, so what we have in our colony as phoretic mites, that means mites that are adults, not counting the ones below the capped cells. We can't count those. We didn't sample those. But this gives us at least an idea that in that colony, there are 132 mites if all of these numbers are close. That's a lot of mites. So even at 1/3%, there's 132 mites transferring viruses in that colony. I'm just trying to get you to understand zero is Low is good, low, and 0 is better. But let's go further now. Let's do the 7. Let's say you found 7 mites out of a 600 sample. What is that number going to be? So let's say that we have a 40,000 size colony. This takes us back to 66. Alexa, what is 66 times 7?
66 times 7 is 462.
All right. So if we look at it this way, and you had 7 mites on our sample, means you have practically 500 phoretic mites walking around waiting to jump into cells on your 40,000 bees. 500 mites carrying viruses. So again, I want you to understand, using the methods I'm teaching in this course, it helps you achieve the lowest mite count possible. Now this is really good, 2 mites out of 600. That's basically 1 mite out of 300, right? So that's really good. But as you saw, we need to keep at it because the mites are going to grow. So for example, in your house, now this might get kind of gross, but in your house, let's say you had 2 cockroaches in your food cabinet. Are you going to accept that? Absolutely not, right? You see 2 cockroaches, you're calling the exterminator because you want 0 cockroaches mingling with your food. Let's say that you have 7 mice in your house. Do you feel good about 7? You know, how many mice do you have in your house? Well, we only have 7. Well, no, if you see 1 mouse in your house, you're setting the traps, right? You want 0 mice, 0 cockroaches in your house. And mostly a mouse and a cockroach, they never bite you. They can transmit, diseases and bad stuff, but it's rare. And so it's not a threat, really. It's just gross. But mites do bite. They are a parasite, so they are biting the bees and they are spreading viruses. So you can see how badly this is. Bees feed each other mostly through glands and through mouth-to-mouth transmission of food. So anytime the bees have viruses, like in their mandibular glands producing royal jelly, feeding the larvae, that means they're transmitting viruses through the mandibular gland, royal jelly, worker jelly, into the developing larvae. The developing larvae are getting the viruses. They feed the queen royal jelly, so the queen has viruses. Goes on and on. Enough of all that. But anyway, this is what I want to teach you to do, is not really sample to see what you have to do. Sample to see how well the results are from what you are doing. Does that make sense? Do what I'm teaching you. Sample to see if what you're doing is working. And if it's not, then we bring out the big guns like formic acid or oxalic acid. Okay? That's the mite count. That's the number count.